Hello, folks, and wait a minute. Okay, yeah. Hello, folks, and welcome back to the broadcast. It has been a little bit. We're still working some stuff out. Hopefully, we're going to get things running a little more regularly. We are starting early enough today that I don't have the Twitch stream running, so it's just the two right now. We're going to be continuing with coding today, as may be expected. We are going to be focused on debugging today, or at least performance review. The issue we're facing is that the amount of code that we're executing per entity and the type of code we're executing is too much of a burden for the system. Now, I think there are things that we're going to be able to do, but we're still running into issues with things like rendering becomes a cost. Messing with that multi-mesh is having a cost, so we need to look at that. And like I mentioned, the execution in the movement, how much processing we're doing there is a cost. We've already seen some ways that we're getting a grasp on where the cost is, but that's not a great thing where it's ending up. But before we get any further into that, let's check in with the kitties. We do have Ember in her spot across from the keyboard, Sky in his up in the cat tree, and Sherbet in his next to the window in the little house. Sammy is over on the shelf, and Mason is on the gray blanket on the bed. Now, we have been experimenting. One of the things we may need to look at is that the mesh renderer is perhaps too expensive. We might need to look into rendering it as a sprite or similar, or just a node with a attached like texture or similar. We're going to need to have the texture information regardless, since this will carry that would carry the information about the texture, and then that visual object could be rendered accordingly. The trick will be getting it somewhere on the screen efficiently. One possibility is not actually setting the texture, and instead setting that in the shader. That's one thing I wouldn't mind trying. One of the issues I've been having is an appropriate sleep cycle here, and it has been a messin' with my eyes. So I can't quite see as well as normal, so I might have to look more closely at it. I think zooming in, which is good for you folks, will be good for me as well today. So get the visual array. If the shader changes work, one of the things we could look into is having a corresponding, like maybe we could put in the entity visual object a texture wrapper, such that it knows about that. Let's get that shader in there first. Where did we put... There we go. I don't know why they feel the need to put this down here. Why is this... Like, oh, I can make it floating. Why can't I dock it up here? Why is this such a completely separate editor? So it's not an int. So this is the current texture that it's set to use. One possibility is to not have that, but I don't know that that's actually going to make anything more efficient. I think where the cost is ultimately living is where we are updating the instances in it. So in our process, we go through and say for each of the meshes that we have, we're going to do a thing. So let me show you where we're sitting right now. Let's go into our debugger. We're going to go into our profiler and we're going to start that. Script functions. Hey there, William. Welcome. We're just getting rolling, really. So I have grossly simplified movement. It just moves to the right 10 times. Yes, William, we're working on the game. We are trying to get things tightened up. So if we pause here. Where are we spending most of the time now? Mostly basic physics time. Well, let's check in with them real quick again. We actually have all 5 of them visible right now. So we've been watching Sammy over on the shelf. But we have Ember across from the keyboard, Sky on his tree, Mason on the bed, and Sherbet by the window in the little house. Many kitty. So we're periodically getting these spikes. And currently those spikes happen during rendering, which is weird. Also, why are we having... Why is that happening? It's 58 milliseconds on physics time, but we're not... What time will I be done streaming today? We're going to shoot for the normal time, so 7 p.m. U.S. Central. We'll see how that goes. Trying to go a little longer, but we've also got to deal with just getting the streams to happen, so juggling that a bit. Okay. Quick experiment with this. We're going to say if try lock. And for each of these, what we're saying here is if I can't lock it, then move along. So it's if we are able to lock, then we will perform that operation. We will remove entities, we will add entities. There's a possibility of a desync here, but ultimately these will never be an issue. Let's see if that has an impact on that lurch that happens. Okay. Okay, did not change the lurch there. We're still getting those. We should, yep. There is an escalating cost in the script functions each time. So we're going to wait for that next spike to happen, if at all. Nope, we get 3 distinct spikes. Start screen. Yeah, I hate that it insists on, hey, you know, blinky Windows focus. I wish that would not be. Hey. Start, we go back, and we are going to... Alright, what's... This is just before it would start to fall off. We get a pretty sharp spike. So... Checking something real quick here. I'm doing well. I'm doing well. Well, mostly. Mostly well. Sleep is still an issue lately, but we're getting there. We're getting there. Anyhow. And what is this live stream? We're doing some game programming right now. We're trying to figure out where all of our performance is going. Wish this would sort better. We're eating a lot of time setting up the templates. Yes. Normally we would be doing a widescreen to Twitch as well, but there are some bandwidth limitations this early in the day. So I'm just doing the two on YouTube. There is a pinned link if you want to jump over to the widescreen format. Can be a little easier to see the code that way. We are spending an awfully large amount of time creating the entities in the movement during this. Like, that is a huge amount of time in apply template for the spiral. Why would this be so much time? I mean, I get that we are creating a lot of them. Like, a lot of them. 10 of these per entity. But why is this so expensive is the question. Calling into create should be in an entity function, right? A lot of this is stream of consciousness. If you have any questions or just want to chat, that's fine. I can pause to do that. Movement pool. Okay, so we're calling it a movement pool. We create a movement object. We clone the template. Cloning the template creates a new instance of it and applies this as the template. So this is one of the places that we're bogging down. We are creating very many of these. So for every entity that we create 10 movement objects right now. One possibility is that we break down the movement logic further. But it's questionable as to why this is suddenly spiking like that. Physics process taking a while. I don't think changing the thread mattered. We're not doing any sort of physics or navigation. These are all the icons, making sure that we're not seeing any weird costs or memory bursts here. And this lines up. We're drawing more things as the physics process increases in time. This makes sense. We have about 50,000 movement objects, and we have about 5,000 entity objects, a comparable number of visuals and positioning logic. It's weird that this is eating so much time because a majority of the processing should be happening in a separate thread. It's possible that Godot doesn't actually thread it, that there's some, opaque footwork in the background. I haven't found anything that indicates one way or the other. So the assumption is that it does what it says it does. But we'll see. So we're limited to 30 frames a second. We're currently rendering into mobile mode. We're doing at most 60 physics frames a second. Let's crop that down and say there can be at most 30. First hitch soon. Okay, it was way briefer that time. There's another. These are all the entity to add collection, and I didn't see that spike up at all. So now we've stopped creating things. What if we don't do any movement logic in it? So we're going to go into here. Just gonna comment those. Okay. It is the rate of creation of movement objects that is burning us here. Hello there, kitty. Welcome. All right. We have at least one thing to deal with. One known thing. Now, this is how many physics frames per second we're getting. It's costing us about 0.1. and we are doing many operations. We are getting occasional hitches with the mice. What I'm guessing is that is a lurch in their update, like it's getting towards the end of the loop. So we have one frame less of physics than we do of rendering. So I'm guessing that that's that hitch, that's that twitch of them, is that they are being... The position update is slower than the rendering update. So there is a period when some mouse is behind the other ones. Okay, so we are going to go into the entity, and we're going to go into... we're in a position where we're just going to reset a lot of stuff shortly. So take that, we're going to put that back. We're going to remove this debugging movement. That movement was entirely making 10 separate add calls to change the movement. I wanted to see what kind of result we could get, and we got similar results just doing this. There's still only one set position call, and this is not cheap. It's not clear why this is so expensive. Fine. So it's possible that it's the shape positioning, but we did gut that. Right now we're not doing any shape setting because that was another point of expense there. It may be that these are created in a separate thread. So it's possible maybe reaching across the memory is getting weird. Unclear. So we're going to go into our catalog, and we're going to set one orbit player. So welcome, Tass. How you doing? So we can see it's 1 for 1. We're getting a little hitch here in the visual frames per second. You might not be able to see it, but that 0 is vibrating. Okay, with spiraling, it's costing us more. The spiral movement is way more complicated than just moving in a straight line. So we can see it's decaying there noticeably. The second number is the largest time that it has taken to get to the next physics frame, as far as the thread is concerned. We are doing tri-lock, and tri-lock doesn't seem to make a difference in that. It's not lock contention, which makes sense. There's only the one thread that deals with it. But this is decaying further and further. It's the... Once you've hit a point where that is low, it's not going to get any better. Because it's taking extra time to clear the frames. So if it got to a frame late, it's now got to run that calculation again. It will be late. We could simplify move spiral, but that still puts us in a strange place. And doing okay, Tass. Today has been better. Sleep is still proving to be a major issue. Just mentioning early, my eyes are a bit wonky right now. So it can be harder to read some of the small text. So just the processing that happens here is not cheap. I know one of the things that we've got in Move Spiral here, repeated calls to some of like the length functions and what that are going to be expensive. Which is why we're calling length squared as often as possible. As opposed to length, just length, because then we don't have to do a square root. We are going to have to change this spiral algorithm eventually, because they don't play nice with each other. With multiple spirals active at once, the things just launch into oblivion. Largely because the spring force functions conflict with each other. All of them will say, I am this far away, apply a vector that accounts for spring force. So it applies 10 times the vector that it should. As soon as it gets close enough, it launches it away, kind of thing. Hey there, Ice Drake. Welcome. So we're going to have to figure out something with just turn angle, but... So while this is a problem, while moving in a spiral is a problem, if we change it to, say, move random direction... I also wanted to test multiple iterations on the positioner logic. This is a sort of depth-first operation that this does. Less of an impact. So here's random direction. Should be right about now-ish that we would see the hitch. Okay, physics time is climbing. There's like a critical mass with largest time that becomes a problem. And we're kind of there right now. So we should see it decaying, yep. Which is the problem that I mentioned before, is once you hit, at least as far as 5,000 is concerned, a little more than 0.1 physics frames per second, it starts to creep downward. Takes a while, but it kind of continuously burdens itself. So one possibility is to have multiple threads. That increases the complexity of the actual thread algorithm as far as how it handles adding and removing. Because when we call remove, we don't want to have to search the collections before we add them, kind of thing. I don't want to have to try to find it by looking at the entity collection, because that costs us each time. I could blindly throw it there with the ad not caring which one it ends up in, but the remove does care. The idea with adding more threads is to add more resources to spinning the physics loop. And I wonder if we won't have to go that way. I'm still puzzled as to why one of our regulars here is Parakeet, and they have been doing, Godot development alongside the project to see what they can come up with. And they're consistently getting as many frames per second as they want out of their algorithm at about 6,500 entities. So more than we've got with no frames per second loss. Hey, Destroyer, we're getting there. We are still in heavy investigation mode now because we can see our physics frames per second continues to fall. Once we hit greater than 0.1 per second, it starts to decay. It starts to keep falling behind. Which, while it isn't terrible, we are getting steady motion, but you can see it's a little jittery. Let's fire that up again. Start our profiler. It's the visual profiler. I don't care about the visual profiler, really. No, we'll keep that going. Script functions. Go in, we start it. So physics frame time right now, it's still puzzling why this can take so long. Because again, we've created a separate thread for this. Everything that's happening in the physics frame should be happening in that thread. But maybe that's ultimately not the case, because we are still calling the zones to update them. Okay. Go into our profiler again. What I'm checking is removing things that could be doing stuff. It's very vague, but we're still calling the spawners because we absolutely have to call spawning logic. But what if we don't tell the zones to update on their physics tick? Hey there, Dorothea. Welcome. And, is that Andre? Good opportunity to procrastinate a little bit more. Let's show the kitties. Oh. Looking down, I see Sherbet has joined me. So we have Ember across from the keyboard. She's leaning against that kind of fuzzy tan thing. Then we have Sherbet to the right of the computer mouse. He is the tan and white, kind of irregular tan and white one. Sammy is over on the shelf. She's the little tuxedo. And then Mason is on the bed. He's on the gray blanket. He's a much more regularly patterned tan and white. And then the big floofy one up in the cat tree is Sky. There are 5 cats in total, and until Ember wandered off to get a snack, you could see all 5 of them. Okay. It's weird. How is that happening? There's like retroactive spikes going on. What's up with that? Hey there, Poland. One moment. Hoff has been back lately. Okay, it's weird that we're getting these hitches. Like, they're at specific spots, but it's strange. And we're still ultimately dealing with more than 0.1. No worries, folks. No worries. If you have... I mean, the common way to put it is real life comes first, you know? Taking too much time yet. It does flatten out, and it's possible that this is wrong. But we are seeing the physics rate of processing going down. Non-trivial amount of time on distance squared too, but it would be... Sammy has shifted on us. Set position is still really expensive for what it's doing, but again, kind of dropping the bucket. We're trying to identify scripting functions that have a disproportionate impact. So the mesh renderer is chewing up a non-trivial amount of time. That's not too shocking. So let's experiment with that. We go in here and we just immediately return. So we should see, yeah, nothing renders. Okay. Once we reach this kind of threshold, this starts to plummet. So we can still move around, but we can see that there is still some jitter, and this is decreasing. We have a running tally of the deltas that come into the physics thread. And we have I wonder if there's a way to not rely on the delta coming in from the system. Can we get a time sense in the thread? They are cute kitties, Andre. They are cute kitties. So this technically helps, but not for long. So what if... Again, we are just throwing stuff at the wall here. So kind of what we want is an eternal loop here. We're going to have a break out of the loop function, but we almost want this running indefinitely. So what if we don't semaphore it? This is kind of tricky because it creates a conflict between them. Is there a way for us to... Is there a way for us to get the time from the thread, like how long it's been since the last one? Because if we didn't have to pass delta in here, we could handle that entirely within the thread loop. Update thread. Started. Well, thanks for swinging through, Dorothea. Next. Don't think we have anything that can tally unit time. So we could do things like ensure that a particular delta has passed, which would give the thread time to run at lower entity counts, but that's not really where it matters. Because we really need that number to be I am located in the US, Andre. We could give it more priority, but I don't know that that will change it. We'll try that again. I thought I tried that. Okay. And bind is going to be a value that we pass in initially. So the bind isn't where we want to live. Ultimately, what we're doing is we're looking for ways to speed up the processing on this. Multiple threads would be one way to do it, is that we would have a series of physics update threads. It does create some issues in that we would need to get each thread to have its own, like its own accumulated delta, that kind of thing. And that's one of our key difficulties, is getting that delta in there. Which is why I was kind of hoping that there was a way to determine the time of execution, like how long it had been since the last loop. Can we do that? For working with time data. Milliseconds or microseconds that we need to use for a delta? Busy schedule then, huh, Andre? We don't need microseconds, that's for sure. Okay, so if we use the logic to get milliseconds since the engine started, since the system started, we can always go in and say, if we don't have a proper time slice, then, like, if we don't have a proper last time we set it, which will mean that as soon as we calculate what I'm getting at is I'm trying to remove any sort of binding to the physics process. So as soon as we get rolling with the entity manager, we don't care about the physics step. That's where we want to live here. Because then we don't need to be operating with a semaphore. We're just going to check and see if we have our exit thread here. And we could get rid of this. This should be, well... If last time we don't have a last time, we're not going to process this slice here. But I really don't want to oh, okay, we can preset it. For seconds, get time msec. Okay. And that returns an int. Okay, it's an int. But we'll use it as in a float calculation. Thanks for swinging through, Andre. Last time is equal to... I don't think we want to do this. Let's look that up, though. Okay, we don't want that. Because this is dependent on the physics tick of the actual engine. And that might not change each time we call it, which would make the delta that we have here unreliable. Get ticks, msec. Okay, so we've defaulted it. By 1,000. Force it to be a float. So... do the same thing there. Float is equal to current time minus last time. It's greater than 0. won't need updating entities when we're done here. Okay, so now change all these to delta, just so. That. That. Which will remove our ability to do this. Okay, movement is way faster than it should be. Oh, okay. So, we need to have a last time in here. We update it accordingly. Still not right. But we are definitely getting somewhere with this. We're on to something. Stopping the system like we're doing, we should press escape and exit, because if I just stop the process, it won't end the thread cleanly. These are floats. Let's... Return as an int. Total delta is number of seconds. Should be, yeah, iterations if total delta is greater than 0. Return is equal to iterations divided by total delta, right? Wrap that as int. Get that right. Should just perpetually loop once it gets going. Is greater than what do we call it? Biggest. Okay, this isn't right. This time is equal to current time. Okay, we're currently getting over 100 physics frames a second, which we don't need. We're definitely getting some jitter there. Okay, 30. What this does is it requires it to wait at least 1/30th of a second before it'll do another loop. Which the physics frames per second are still not coming through properly. Um, Slightly under 30 frames per second of physics. Still seeing a bit of a hitch there. Let's up our rendering frames per second as high as it'll go. Okay, we're getting real big jitter there. But by decoupling it from the main thread, we've made some headway here. Now, it's also just the player movement that's doing this. Like, the mice are moving smoothly. At this point, though, as they're getting further and further away, our physics frames are still dropping further and further. Let's our debugger going, our profiler, our script functions. Still occasionally getting those big spikes, but not frequently at all. Nothing compared to what we were. holding pretty steady, but hey there, Mud. We're trying to isolate performance issues. I play a lot of games like the one that we're working on here, with the goal of kind of setting targets. And one of the ones that I've been playing recently is called Rogue Genesia. And one of the notable aspects of that is that the amount of stuff on the screen can get wildly out of control. Like, bonkers out of control. And the game is still handling it reasonably well for how much is going on. That's kind of the bar that I'm setting, is I want there to be able to be tons of stuff rendered at once. Okay, so the processing time is occasionally eating more than we'd like. Let's do a clean shutdown here. Huh. Even when the system was paused, it was still rendering the animation. That's interesting. The shaders work independent of the engine. Not a problem. I don't care if they sit there animating while it's going. Okay. Oh, we've got to get a wait to finish here. Was weird. Okay, good. Okay. We are making progress, though. This is better. there's still more ground to cover. So what if in the mesh renderer, so we're updating information about it. We get each of the keys. Now we could also restrain this and say that it needs to wait at least long enough, because we don't need to like exceed 60 frames a second or something. Okay, we could do this. In entity, when it sets position, it's also going to set visible. Factory dot distance squared to position is less than 1920 times 1920. Hey there, tired. Well, welcome back then. We are going to update the shape regardless. Let's clean that up. We can do better than that. See, it shouldn't be impacting the physics time if this happens, but... So we're heading into about 0.1, which is about where we start to slow down. It's still good. We want to... We still want to check if it's not visible, we don't want to render it. Care about updating entities. Care about current delta or... So that restrains it. This primes it, yeah. So once again, what we're doing here is that we're looking for set. I don't know why it blanked the list there. That was not useful. We're still eating a good chunk of time in the mesh renderer. Everything is off screen now. Pause. Entity movement going by pretty swiftly. Most of the frame time that's happening right now is rendering, but the question is, where is the rest of the physics processing time going? Why is it bogging down? Hey there, Clara. Welcome, welcome. Joining us for some coding. Same variable, just so we're not reallocating. Hello, Sherbet. Yeah. I see you there. So there's a little canvas cat bridge. I don't think you can really see it. Actually, yeah, you can see the end of it on the big cat tree box there. Right to the right of it, there is the tail end of the bridge. There's like a little double back on it that creates a pocket. But that is a little canvas bridge that extends from the desk up to the cat tree. And Sherbet has taken a liking of climbing up that bridge to the highest point on it and then leaping down onto the headrest of my chair. So, like, yeah, maybe 3-foot-ish drop at full leap. So it's kind of a jolt when he does that. So while I was doing that, looking up, was I was watching him prepare to make his leap. This is still a weirdly large amount of time. It's still relatively pricey, unclear why. I still have to wonder if because the movement is taking a very short period of time and then it's costing us a lot to set position. Now, some of that might be our changes to entity there to make it so that nice. Okay. So we set this to true, and that means the next loop on the physics thread will hit this check. It'll say if this is true, then I exit the loop, which will result in the actual thread itself finishing in getting past this blocking call. Hello, Sherbet. Yes. So you stop scratching my back. So this is good. We're making headway. We're making headway. There is a smooth transition, but it eventually starts degrading. Biggest delta starts increasing, which is determined by here. Say, where are we currently? We get that delta. If it's at least 1/30th of a second, which is About 0.033. Let's verify. Yep. Okay, actually, let's... Many entities being created at once. Yes, yes. Seven, 8, 9, 10. Very rapidly is still chewing up the time. But we get way further. Well, we get further before it eats up the rest of it. So we still have the problem that once you get enough entities, it starts to eat more time than we can handle. All these movement objects. Over here, and we start our profiler again. Give pause. Look at our script functions. Entity move is taking 2.8 milliseconds by itself, which doesn't seem like it would be a lot, but it adds up. Where are we using up 33 milliseconds for? I think, actually, no. This is about 30 frames a second. So this is fixed. So this isn't really an issue. Was misreading that. Okay, we're going to change that from biggest delta to time that it takes to complete a loop. So we go all the way down to here. Time to complete, which is the same as all of the others. So this is how long a full loop takes. So it's iterations over the movement collection for all of the entities. So by the end of this, by the time it hits this 5,000, we have 50,000 things in the loop, and we're trying to do that as fast as possible. Since we're running the loop as quickly as we can, one possibility would be having the two threads rapidly grabbing from the collection and saying, I shall now grab the next thing. Part of the trick with that is going to be making sure that we can get that lined up. Because we have adding to the collection, removing from the collection, and we have processing it. If within the same thread I said, okay, I'm going to break this apart into multiple threads, and each one of them is going to handle some particular offset, that might work. So, like, they start at X, and they increase by X plus 1. No. They start from 0 to X minus 1, and they increase by X each thread. So if I created 2 threads, then X would be 2. So we would start at 0 and 1, and then it would say, okay, then we have 2 and 3, and then 4 and 5, kind of thing. Left, right, left, right. And since each one of the threads could do the add remove logic, but iterating like that means that we run into the chance of conflict. Because if any one of them is iterating over the collection and some part of it changes, then that index isn't accurate anymore. And that's a problem. We could try subdividing it, with each one of them trying to lock it, pop the first thing to remove from the front, and saying, okay, I'll take that one. I think that's viable. Okay. So here's my thought. Instead of just having the one thread doing this, we have multiple. What each one is going to do is have its own entity collection that it will iterate over. We'll start with a this is your index on each one. So they'll have a variable that we're going to bind coming into it. So it will be a permanent index on it. So instead of going over, there would still be a single to remove mutex. But since each one would have its own entity collection, there would not be an entities mutex. At the start of each loop, they're going to look at it and say, do I have We need to make sure that there is some sort of space indicator on it. Because we don't want one of them to get into the position where it's moving fastest, so it always is the first one to add to the collection. Like, it will constantly be the first thread to catch the ad. Well, hey there, Skylar. Welcome to the broadcast. Good to have you. Now, you are in the tall format. If you would like to be in the widescreen format, there is a pinned link. But in any event, welcome. We are doing some performance refinement, some debugging. We're getting there. That's not even remotely an issue. It would remove our ability to have total delta. I'm a nanotype. I'm the prototype nanotype, the second product line from Kappa Corporation. In a totally consensual and planned fashion, I have been appointed the administrator of the Kappa Corporation Kappa factory. Everything is fine here. One second here. We are going to keep that. We'll keep that. What's going on with entity here? Making a quick source control commit here. Okay. And okay. Hey there, sleepyhead. Welcome. Actually, since Skylar hasn't seen, I think, going to... I should have a macro for this, but I don't. There you go. Hey there, James. Welcome. We're just about time that we can start the Twitch thing. I do. Big stompy boots, too. Was what always there, James? Oh yeah, the legs have always been there. They're just usually off camera. Boots. Well, hopefully we will get the rest of the bugs stomped here. Let's get that Twitch stream going as well now. We've crossed into the time of day where I have the bandwidth for that. Okay, so this still costs us a whole bunch. But we're getting better. So this runs as fast as it can, at most 30 frames a second. We could still throttle it more. But so this is 10 movements per entity. What this is amounting to is ultimately the physics loop is iterating over 50,000 things. Which is clearly not great. See those big hitches there. Not currently, or at least it's not supposed to. Now it will process them. I could add a kill event to that. Well, then you won't be able to necessarily hear this press start, but welcome. And for those not familiar with the channel, there are now 3 streams going. Up until a few minutes ago, there were 2. If I seem to be talking to somebody you can't see in the chat, that's why. There are the 2 other chats. There is currently a max entity count. There are 5,000 currently. Each of those entities has 10 different movement patterns, though. And that's where we're hitting our limit. In a realistic sense, we're probably not going to hit 5,000 things. Right now, we're producing a huge number at once to get there. So this is kind of a catastrophe case as far as stressing the system. But if we can't handle this, then there's the risk that the game does grind to a halt, and we start getting physics aberrations like this. It should not be. So this is the time that it's taking to process all 50,000 of these. And we are still getting this perpetual degradation because if it takes so long to loop, well, no, we shouldn't be getting that. It's steadily bogging down. So one thought is, again, to make multiple threads for the physics handling. Potentially we'll make one for the rendering as well, so that the processing of the 5,000 entities for the purpose of visuals is handled in one thread. We could also do the collision updating in a thread. That will be trickier because that is currently a tangible entity. Like they are things that exist. They're doing nothing at the moment, but they exist. So what else can we do to speed that up? Because it's the time looping on that. Now, Parakeet over there has been working on some similar stuff, and they get much better results from the physics. I do think that there is an aspect of cost to call into another object. Like, this stuff burns us somewhat. Just do this to simplify some of this, make it a little bit more legible. The reason you get variable speeds is there's 10 instances of move in a random direction. Each of those instances has a random direction calculated, which means any one of them might oppose each other. Like, they could cancel each other out and just stop the thing from moving. Okay, instead, let's make them orbit along with that. So we're going to try to drag them back in. Just so. So the orbit is desperately trying to keep them inside the loop, whereas the random motion tries to push them back out. So we can see a little bit of wiggle there. So I don't think it's visibility that is ultimately causing the problem. As in, how many things we're rendering, even if they're off screen. It's a non-trivial cost. We will need to refine that. It really does seem like it's raw iterations. So I could make extra threads for physics, such that we have multiple of them having their own entity collections. Each one trying to grab, what we're going to do is say it grabs one at a time before it goes into its loop, to make it less likely that any individual one will monopolize the add collection. And any time there's anything in the remove collection, each one of them will look at the first thing It will lock that collection, look at the first thing, and find out, is it in my list? If it is, it pops it, removes it from its collection, and then proceeds with its loop. That way, only the list is only affected if one finds it. It's not ideal because that means that each of the threads will waste time, but could be worse. I still wish I knew why we were tanking performance so much. Why is... Let's get that up and running again. So connected. We're going to pause real quick. Get those script functions attached. We don't actually care about this because the physics aren't happening in the physics frame. There is still processing going on here. I need to isolate those because they don't need to happen. Hey there, Theo. Welcome. We're doing extensive debugging. Why you gotta do this? So entity move is taking up 50 milliseconds, which is hefty. Am I a real cartoon? Hey. A droid with cat features. We are still eating a huge amount of time initially making those movement objects. Upwards of 50,000 calls, Parakeet. Within the move function, we're going to be calling move random direction a whole bunch. Yeah, sort of, Theo, sort of. Okay, wait a minute. What other parts of entity move might we be dealing with here? Isn't it, Theo? Isn't it? I mean... But yeah, normally not. Welcome, Pixel, welcome. This moving structure is for dealing with navigation. We're not currently doing that, so nothing actually changes. Wait, where are we? Okay. For those just joining us, we are working on optimizing the movement logic. So this is taking some period of time as well. But as far as scripts are concerned, creating the movement entities is eating a lot of time. Okay, so now we're past creating them. Pause, we're going to get... So this should remove the movement creation. Yeah, that's 1 of 5, Skylar. Let's see how many we can spot. Should be able to see at least 3. Yeah, 3 out of 5. Sky is the big fluffy gray one that you can see there, filling most of a camera. He's got that white stripe down his back. The black and white one, the little tuxedo, is Sammy. And then the gray and orange one is Ember. Ember is the smallest of them. Sammy is the second smallest. Sky is the largest. They're very mellow cats most of the time. I joke that stream time is nap time, but that it is very accurate. All right. Okay. To unpause. Oh, come on. I wish it wouldn't do this. Because I need to be able to see the actual performance values, and I can't if it keeps clearing out this collection. That is moderately frustrating. Okay, 1 frame ago. So 15 milliseconds, that's containable. We should totally be able to do that. We are spending no time in physics 2D or 3D. We have no sound, so technically we shouldn't be spending anything there, but I'm guessing there's some sort of built-in process that has to spend some amount of time. We should be getting a lot more performance than we are. Perhaps someday, Skylar. Perhaps someday. I wanted to behave at low performance values, but that is a good point. We can we can do a test in Forward Plus here. And see how that goes. And hello, Minty. Hello, welcome. This will let us leverage more of the power of it. Do I like anime? Yes, but generally I've taken to liking the light novels more. I find that a lot of anime tends to drift in what I expect they consider more marketable directions, sometimes to the detriment of the quality of the writing. Once I've got everything else working as I'd like, Minty, the next thing would be to start adding different player characters. At the very least, like play variations that you can pick, whether they be challenges, starting templates, that kind of thing. Just to give some variation. Do I have any favorites? So, my original favorite, and still one that I hold dear, is called The Slayers. That is a 90s to 90s era anime. Okay, we are starting to eat time still. Holding better, but we're well out of range here. If the delta is reaching that, then we have a problem. More recent ones, and again, light novel is what I'm going to refer to. I really like Overlord. I hate the Overlord anime. It is terrible. I like the light novel a lot. This is the largest delta. We can see that this is decaying. What I might do is make that a real-time delta. We'll see. In a similar vein, I'm still reading Saga of Tanya the Evil. Anime was decent in that, but just like in Overlord, they cut out a lot of the nuance of what's happening. The inner monologue of characters gets removed in both of those in such a crude way that it detracts from the story incredibly. It's bad. Add to it that the Overlord anime has a lot of cut corners in the animation. Anime that I have liked recently, The Ranking of Kings. I haven't watched the second season. I know it's there. I'm interested in it, but it has a bit of a slow startup, and I have to kind of choose where I spend my time. And that one has constantly gotten bumped, you know? But the first season of Ranking of Kings was amazing. Especially that last fight sequence was just excellent. Just so well executed in all of the ways. Okay, in Forward Plus, it can hold better. The minimum seems to be holding at about 12 frames per second, which is better, but we still get this chunky movement. Clonk, 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 clonk. And you can really see it when these things have to move. There's some other anime that I've liked over time. I mean, there's the classic, like, Saturday anime stuff from the very early, like, English releases of anime. So your Vampire Hunter D's, your Zyrum, that kind of thing. Robot Carnival. Hello, Garrett. Welcome. And we are still getting a decay here. Garrett, I'm making a Bullet Heaven game. The kind of game that is, vampire survivors, that kind of thing. That's right. Death Note was a good anime. Death Note was definitely a good anime. I do like the first Dragon Ball, too, Dragon Ball and then early Z. Really before Namek Z. Not currently, Parakeet. So in the collision zone, I actually have that extracted. Actually, wait. No. Okay, we don't update them, we don't add them. Generating errors. No impact. No tangible impact. But it's a good thing to remove, just to be sure, So what this is that by returning in these, we never... Like, we should never get this kind of thing happening. Yeah. We could prevent that decay. We know the rendering is non-trivial as well, because we have to iterate over each entity, and we're messing with the visuals accordingly. But I don't think that's eating the physics time. It's that over time, it's just taking longer and longer, which is weird. Yes. It's done in a multi-mesh instance, and we have an extra layer in there where we go over it. So essentially, we iterate over it twice. So we have a like a 2x performance here. We iterate over the whole, not quite a 2x. We iterate over the whole collection and say, is it visible? If it's within a screen's width, essentially, of the center. Oh. And okay, we're full. So it is flattening out more objects than I'd like, but what you gonna do? Okay, we have a huge number of objects. I wonder. It should extend a modifier. Modifiers. We've actually had to remove the jiggling of the enemies as part of the debugging there, Lunar. Yeah. If they were nodes, it would be a real problem. We started extra early today, Garrett. I'm trying to start earlier when possible. Though more recently, I'm trying to start at all when possible. But hopefully, we can keep rolling here. We are going to mess with this a bit. What I did with this is, well, actually, we need to test it now. So we've set it to reference counted because that should mean that the thing is going to properly track how many times it's got a that it's being held. Should be about right, and no actual difference, so. What else do we have? Because this is eating a lot of time when we're creating them. Still plummeting. All right, let's shift the experiment again. They're not going to move it all in that. Instead, it's like last time. Do that. We're telling them to move to the right 10 times. We're just doing a series of math calls. We do get this blur here. So this is without movement entities. So we've still got to deal with that blur. That blur is a problem. Why we're getting that blur, not clear. One possibility is that the multi-mesh is getting thrown off by the constantly redrawing, you know? What this does is it lends some credence to the idea that calling into the movement objects is part of the problem. Okay. We're going to put these back, but it won't matter because in the entity manager, when we eventually call move, we're not going to call move. position plus delta 0. Okay, so what we're doing is instead of moving the entity, we're just setting its position one at a time. Hey there, Galaxy. Welcome. We're doing performance debugging. Okay. So when we were discussing this on the Discord there, Parakeet, one of the thoughts that I had was that calling into the movement objects was part of what was burning us. And I feel like this is confirming it to some extent. It's just setting the thing's position is seemingly fine. We are getting a very consistent delta here. I know we're a galaxy. We are a small enough channel that it's easy to spot any one individual coming in. Though I can't guarantee that I won't get hyper-focused on something and miss somebody. But, you know, when I can. So this is a very simple movement calculation. Let's amplify this a few times, because okay, this isn't an accurate test because this would only be called once normally. We're going to make it move the same distance that it was moving. But when we call set position, we do mess with an object that is created outside. Messing with things that are made outside, messing with other objects, let alone messing with entities made outside of our current thread, is expensive. Entity is largely the physics handler and kind of a manager for some of the other stuff. Like it adjusts the object that says how to render the entity, and it adjusts the object that says where it is in collision space. It does not directly adjust the transforms. It changes an object that the multi-mesh will iterate over during the process call. Because, yeah, messing with that multi-mesh is not cheap. Like, it renders zippy, but... yeah. Wonder if we can... So we know that's more expensive. The fewer times we call this, the better. Let's do a... or I as an int in 10. Do that. Should be the exact same thing. We should get a substantial drop as it goes. Yep. Okay. Let's break this up here. Edge case here. Hello, Erebus. This whole player factory object eventually needs to go, but we'll get there. We're doing pretty good, Erebus. Doing pretty good. I am reminded that we are about 4 and 3/4 hours in, and I haven't taken a break. So we're gonna do that real quick. I will be right back. And we're back. Those that haven't noticed, I did add about 11 new tracks to our playlist here. Added some stuff with some strings here. I especially like cello stuff, but the music provider that I have access to doesn't have good categorization for finding instruments that aren't like piano. Categorization is spotty. So if we were to break the handling down into alternate functions within the actual entity manager, that would be akin to what you were doing, Parakeet. So we can try some of that next. Because if we look at to that, then at the end, we say entity position plus 2 move. So we're only setting the position once. We're only messing with outside objects once. Didn't seem right there, but I don't know why the early ones rocket propelled out, but we're not really interested in behavioral anomalies so much as we're interested in handling this cleanly. And again, minimal usage of the objects, the outside objects, seems to be critical here. I think if we pair that with threading manipulation of the meshes, but that runs into the problem that the meshes are going to be outside objects, which it would be messing with quite muchly. We have to call set instance transform over and over. Or if there was a way to do a mass set, so there's no risk of the iteration taking so long. Just gonna disable that for a moment. No, I think it's the jittering in the transform setting there. See, I think this might be a multi-mesh aberration we're seeing there. All right, let's remove the rendering here. Hey there, Chloe. Welcome. Doing okay, Chloe. Doing okay. So when we're creating an entity, it comes into existence outside of the entity manager. Same with its stuff here. But since I can interact with the entity, we shouldn't be having a problem. Yeah, the whole thing is able to operate. Like, we can call the entity. And when we're moving them, we don't invoke anything about the entity aside from movement. We're making a bullet hell game. Entity refers to any sort of kind of character on screen. The player, the bullets, monsters, that kind of thing. So test on this. Well, thank you, Chloe. Thank you. I appreciate it. Why was that so impactful? The next movement stuff didn't do anything. That literally wasn't doing anything. It set it to null and then nothing interacted with it. It was only that during the move we would say, if it's something, do stuff with it. But it was never something. This should be comparable. Let's look in the entity move. I do, Chloe. In the lower, let's see, where are you? Okay, so for you, top of the screen is one of my 5 cats. That one's name is Sky. He is the largest of them and very fluffy. So go in, iterate over the movements. We're going to do nothing at all in the actual movement call. In the manager, we're going to call move. So nothing moves. It springs into existence. But we're still making 10 calls within the entity. While we're waiting for that to fully spin up, we can see 3 of them. So Sky, as you were witnessing before, Ember seems like she's looking for something to play with. But we have Mason is the tan one on the bed, and then Sammy is the tuxedo on the bed. Hello, Ember. Ember is coming to sit with me. So this is with no movement logic happening. But we are calling into entity move. Just that we're not doing anything in it. So this is going to be... Now, instead of a pass here, we're going to do everything other than the actual movement logic. Ow. Ow. Ember is dancing on my collarbone right now. Ma'am. Okay, we're not calling the actual move function, but we are doing other processing. Non-trivial increase. And it is creeping up. If you got a question, fire away. Okay, so that got up to 0.66, which is about 15 frames a second, though it was handling more than that. I'm sorry, that was the highest time. Let's... Let's do that. Make this number fluctuate like crazy, but... This number is how long it takes to complete an entity update loop. As long as this stays below 0.03, then we're in really good shape. So it's right on the verge. Well, as I mentioned, I do prefer light novels more than the anime. Almost uniformly, I find the quality of the light novel that they're derived from to be better. But as far as anime goes, recent anime, well, my all-time favorites, The Slayers. I still love that one. I actually found out that there is the light novel that Slayers was derived from actually has some darker moments in it. Still hits the same story beats, of course, but it can be a little bit darker than the anime was. And they also have an audiobook that is narrated, at least the English is narrated by the original English voice actress, or somebody that lines up that voice perfectly, which I thought was cool. Then a recent one, Ranking of Kings. I liked the first season. I haven't sat down and watched the second, so I can't speak to the second season. Previously, I would say, and hello, Drew, and welcome back, Galaxy. Previously, I would have said Made in Abyss. But I've been following the manga of it, and I hit a point where I feel like they've crossed a line with some of the innuendo that they're doing. And it's a line cross that makes me done with it. There's some real ick going on there. Same way with Dragon Maid. There are definitely great elements to it, but there's also some noticeable ick, and both of them have crossed the line for me. Previously mentioned Death Note. I did like Death Note. One of the best things about Death Note for me is the ability for them to turn wildly mundane things into high drama. It's akin to like Yu-Gi-Oh!, where they make a huge deal of something as mundane as drawing a card. With Death Note, the stereotype moment is the potato chip scene. The I'll take this chip and eat it. That one, I do also like a later scene in it that has essentially a lieutenant of his writing in the book for him. And the way that he's writing in the book, the way that he is wielding that pen, as if he is as if he is having a knife fight with the book. You know, lunging in and a clash of steel kind of knife fight. The scene is him writing in a book, but it looks so amazingly dramatic and action-packed. Yeah, as far as what I'm currently thinking, that would be kind of the top three. There have been other ones that have been good recently. Hero Academia was decent. I have read the manga up through kind of the post-apocalyptic setting. Berserk definitely has some ick to it as well, but I have read through everything that's available. Still waiting to find out how well the person that is stepping in for the original author who died is going to do. What else? As might be apparent, we are making some headway into identifying the problem space. I get the impression that we may need to reformat how we're approaching the movement objects. And instead of a series of objects, we might need to look at them as a series of callables. Break things up, essentially. Because there are aspects to positioners and movements that may make it possible for us to make them stateless. It will not be guaranteed, though. I don't know that we can do it with positioners for certain, because positioners do need to have some memory currently, require some memory of the previous projectile. Like, it needs to know which segment it's dealing with, and that segment is unique to it. So, if I have a spread of 3 into a spread of 3, the first spread of 3 knows that it's doing 1, 2, 3. Then each of those 1, 2, 3s is then a subsequent 1, 2, 3. with each instance of that having its own kind of ticker. Now they handle this by each instance having a call in and saying, oh, I am... I wonder if that's part of the problem. Anyway. Ideally, if we change movement, I would also like to change positioners to do the same thing to reduce the burden of spawning them. Let's... as a entity void opid void to 6 delta So this is kind of where I would like to be, is that here's the entity, here's the time that has passed. And have any of the logic handle that. Positioners could be different because they are fundamentally dealt with differently. They're kind of a series of calls until they're done. But there's some nuance to how that's happening now that we're going to need to deal with. But call it, and we're going to pass in entity and delta. At set position, and it's going to be entity target movement. Fire away, Chloe. Okay, we're moving way too fast. But it's still a good test. Way too fast. So we're still getting some visual flicker here. I don't know if that's to do with just the crazy speed that we're dealing with. Which could be interfering with some of the logic as well. Call this 10 times. And it accepts the delta here. entity, and its target movement is... Makes sense. I enjoyed Attack on Titan until the outside world got involved. I feel like Attack on Titan's storyline started to get real hat on a hat. Started out solid, basic concept, still good. Okay, still not ideal. But we've got to be on to something here. Delta is consistent. Oh. Entity.target movement is vector 2.0. Hey there, Colin. And, you know, I don't disagree entirely with that. Fairy Tail suffers... they get into Dragon Ball escalation territory where it is impossible to judge the capabilities of a character because the effect of any of their moves varies second by second, you know? Additionally, they have a whole lot of, like, poorly written, oh, we're friends now moments. The iconic thing of that, and it's not terribly late into it, is the Iron Dragon Slayer. You know, the punk rock looking guy. In the arc that he is the villain, he literally crucifies one of their friends. And in subsequent seasons, hey, we're buds now. Like, she resents him a little bit, but she still seems to be like, you're a coworker. We're going to be businesslike and polite going on. And they do that over and over. I've heard good things about Demon Slayer. I've only ever seen the first episode, like maybe half of it. Okay, calling a method to do that. So this is calling a callable. So if instead we just said entity.targetMovement, we're going to do the same thing that we do here. So this is exactly what is in this function. Way cheaper. Just ridiculously cheaper. Like, we're at 4,000 and we're still at 0.01. So the question becomes, can we get this level of like flattened logic into it with the variations? Can I avoid ever calling a function? And I think the general answer is no, I can't. So we've got to find some other ways to speed this up. Your eternity. Rings a bell. Sounds familiar, but I haven't seen that one. So we've still got visual hitches here, and part of that is that it's out of sync with the way that the movement works, or the visuals work. And that's usually where Ember naps. Sky will come over there and like snuggle up with her. Usually he'll leave before she does. But I figure she was done with him earlier. So there's not a lot happening on screen right now, but that's because I'm trying to think through what other options we have. Because so we've got this where it is direction. Okay, So we are instantiating a instance of move random direction. This is going to be inefficient because we are doing this repeatedly. Let's move this up a little bit. Don't need this function call here. Yeah, it's a move random direction type. And delta is non-zero. Move random direction should be doing a thing. Oh, it doesn't have a targeter, that's why. No, it has a targeter. Right? Yeah. Okay, okay. Movement. This muddies things a little bit. Let's... This will make the mice wiggle around like crazy, if it works. Okay. Yeah, we're spending 16 milliseconds in move straight line. No, that's not possible. Move straight line is stupid simple. Yeah. What's happening is that we're spending that much time on apply template. With this kind of game, Chloe, the general goal is to level up and acquire more firepower such that the swarms of enemies converging on you can't touch you. They're called bullet heavens as a counter, as a kind of a mirror to the bullet hell genre. In bullet hells, there are piles and piles of enemy shots coming at you, and a core part of the gameplay is very gracefully weaving amongst those bullets. Bullet heavens are set up such that all of those bullets are coming from the player, and the goal is to essentially make those bullets as numerous and effective as possible. So this is the same problem we have when we're creating the entities, is that this template, apply template, is very expensive. Why it's very expensive, that's not clear. So again, move straight line, very simple. Okay, we're going to leave catalog name, but we're going to remove the icon. Yeah, tanking hard, building it the way we're doing it. Effectively, Colin, Vampire Survivors is the reason that that genre got a name. The arrival of Vampire Survivors, solidified that as something that people wanted to make. It's kind of like, I have to consider it similar to Cookie Clicker and the idle game genre, you know? To my understanding, Cookie Clicker is the thing that propelled that genre hard forward. I feel like there were examples before that, potentially. But it's kind of the example, you know? You know, for better or for worse, how there is a genre called a Souls-like. And doing a dash-like is a terrible way to define a genre, but I get why people do it. It's just, once you understand the underlying meaning, you should choose a name that is based on that underlying meaning to avoid the comparisons. Like, I'm confident that there is a full generation minimum of people that don't know why a Metroidvania is called a Metroidvania. You know, people still do, and people can find that information. But the name invokes information that the readers don't have. And they only get an idea of what that information is based on finding out what games get that tag set to them. And welcome back, William. So the apply template is burning us. And we're going to do it a whole lot with the current test case because I am making a new one to use on each entity each time. Movement, and we are going to so if we don't have one set, we're going to set it. What this does is that each entity is created. We'll go into here. So the entities have no movement settings. We're going to create a move random direction, and we're going to attach it to the entity there. Okay, still low performance. Calling into the movement object is burning us. Calling into anything costs way more than just doing the math directly. This is a problem. This is a big problem for our model here. Because again, we instantiate one of these. We call it 10 times, and then we use the value. This is a very truncated version of doing this. Lunar, the plot of this game will be focused around my backstory and the general fiction thereof. William, time and familiarity. It's generally not something that is requested, it's something that's granted. As Tass says. So we need a way as much as I can figure out how to do, Lunar. The general concept of starting out with catbots that are entirely benevolent and then progressing from there is the vibe that I want to go for. Mentioning Cookie Clicker is actually kind of lines up, is that while it will happen faster, things will escalate. That's the goal, is not there are just more monsters, it's that elements of gameplay will start to escalate. Some content will appear based on how far it's been going. Hey there, Rice. welcome. I'm gonna do this. This should have 0 impact. Yep, and we're escalating way too fast. About 3,000, we dropped down to 20 frames a second. We can definitely do better than that. It's figuring out how to do better than that. Even calling into a method on the same object triggers problems. Right here. So this is calling a local function. We are not directly interacting with the movement logic of a movement object. We're just updating a variable on that entity. We can see it's creeping up as we go. That's to be expected. As long as it stays under 0.033, then we're in great shape. But if it exceeds that, we start to have a problem. That means that we're not getting a full 30 frames a second. I can unbind that. So this is calling a function 10 times. What if... Not going to mess with the entity's target movement. Instead, we are going to make this return a vector 2. Going to turn that. Then we say to move equals that. Really hurts, Ember. Really hurts. Okay, calling into a function 10 times, we are not touching the entity directly during this. We're passing it in, but we've ceased to do anything to it. Reasonable. We're still getting close to threshold. Yeah. At about 5,000, we're already over that limit. So instead, let's also look at this. It's greater than 0. This is unbinding it. Run physics as fast as you can. Which makes this number bonkers to start with. So we are still running into the same problem here. Again, this is physics frames per second. It's not accurate. Then we go in, so we have moved this. And if we look, it's vector 2. That times delta. So now I'm gonna make up your mind, Ember. Well, you stopped petting me, so I need to put my claws through your collarbone. This is the way. Okay, this is exactly what that function does. This function returns this value, and we add it to this. How small this number is. About to reach 3,000, and we haven't hit hundredths of a second yet. So I could thread this further. I could add some more overhead and have multiple threads working on each one. We need to figure out how to pass a specific value to each thread. But I ultimately don't think we'd actually need that, since the end value is universal. If one's going to end, they all end. Yeah. We're at 5,000 and we're at 0.01. Our frames per second is 2 to 3 times higher than it needs to be. What that means is we get a much smoother animation too. Okay. So how are we going to do this? Well, first, we're going to take a look at the changes that I've made and see how many of them need to be stored. pause for now. Maximizing desktop-oriented performance. Discard these. We don't need those changes. Okay. Okay, one area to check is going to be what happened? Okay. So adding another thread is one path that we could go down. I think there's some merit to it. We do need to have a way of differentiating, so we're going to have to do the thread bind on them. And the entity lock will no longer be needed as a result. The entity mutex won't happen because each thread has its own entity collection that it operates on. Oh. Which means we don't need a universal one. Each one of them can have a collection up here when it enters. Yeah. And the entities to remove and add are universal. So we start with an empty array for them. How are we going to do this? Because I would still like to be able to get frames per second out of it. Oh, okay, we can do that. And we'll update this to actually store off the one that's taken the longest again. So we don't need the entities mutex anymore, and we don't need the semaphore anymore. Of red. That. Into 2. Thread as a thread is equal to thread dot new. Two. Thread count. Threads. I wait to finish. Run it to the collection, start the thread. This is shut down the threads. So it will set the exit condition, and then it's going to make sure each one of them is finished. That should totally work. So if we can get the lock, we will consume everything. This one needs to change. Okay, so we're going to make a collection here, entities remove, which is an array of entities, which is equal to an empty array. If we find it, we are going to erase it here. I'm going to say entities removed dot append entity. So we found it. In entities to remove. It's removed. Say entity removed. Entities to remove, erase, entity removed. This could be more efficient, but we're not worried about that. So what this does is for each one of them, it tries to get this lock. If it can, it looks at the collection of entities to remove and pulls out any that are in there that it controls. But otherwise leaves the collection intact. If there's anything in the add collection, it sucks up all of them. I can't actually do that. So with two threads handling it, okay, we're gonna add another mutex. This is the count mutex. X.new. What this mutex is for is for messing with the count of entities. We have to be able to get this lock in order to add or remove entities. Ooh, 0. This creates a risk surface as far as collisions between them. We can do a try lock on it. So if we can get the count mutex, then we're going to go through each of those and we're going to mess with it. So only one of the threads can consume the collections at a time, because that changes the number of things. This, if we find it and we remove it from our collection, we reduce the count by 1. When we add them, we add it, we increase the count by 1. That, because that will be okay. Then for frames per second, int time.get tick milliseconds number of milliseconds. So divided by 1,000 is fractions of a second. A float. Then in our ready, float divided by 1,000. These are milliseconds. Again, divided by 1,000, we get fractions of a second. This is the first time slice that the whole thread manager saw. So this will be the start. So then when we're getting the physics per second, at the time we ask, we say, how long has it been since start? Like that's the starting point. And then let's get all this in here. Excessive parens, but you know. So this is the current time minus the start time. Now we won't set that in ready, actually. If not, start time Then start time is equal to number. So this sets it for the first time if we need to. It's still weird. And iterations is greater than 0. Weird that that's so high to begin with, but I have to figure out where the math fails, you know. Okay, then in the game, when we are updating our visuals, we're not going to look at entity pool created. We don't care about entity pool created. We'll just jump to that, which is actually now total entities. Okay. Moving right along. Okay, we need to make sure that we don't overload each thread with this. Let's see. That'll be text later on. Okay, space available. The largest between the two of them at 3000 is 0.013. with 2 threads devoted to physics. Okay. Now if we go into the entity manager and we go into our update thread, add them. Now we're going to move them. So call entity move. Look in our catalog. A double thread. Very busy. I get the impression that we might need to move some of the creation logic into the thread. But that shouldn't have such an impact. But let's stress test this. How about 5 threads? It holds much longer. Still far too slow. Start this wrong. Yeah. In thread count. Wasn't a proper test. Now 5 threads. It holds for longer, but that's still not enough to handle 10 movement objects. Right? 1 thread per movement object. If anything, that many threads being created seems to have made it worse. Well, the first thing to spike it, Tass, was setting it back to use the movement objects in a group of 10. So every one of these has 10 movement objects that it's iterating through. This is with 2 threads. So we're actually getting FPS hits here. Which is interesting. For the lulz. This stopping implies to me that the visual thread or the rendering process is choking now. Physics process is taking a while. Why would physics process take a while? Like, we're getting there. We're getting there. I need to figure out why this number is so wrong. That would require... because we're going to generate a lot more iterations, but that's okay. There is no collision handling at all right now, Parakeet. We're not even creating the shapes. This is without collision, without navigation. It's just raw movement. Just 2 in the thread count. It seemed like we were doing better. Still overrun, but... here, get our debugger attached. Set. Rendering the mesh is noticeably expensive. We're messing with the mesh compared to other things. See, the 2D and the 3D physics engines aren't doing anything. Physics 3D not doing anything. That's good. It shouldn't be doing anything. Physics 2D apparently running off to hide somewhere. Yeah. Entity move. We can only have so many threads. Well, more of this come next time. I think we've made a lot of progress. I don't know that the threading is the solution, which is unfortunate because that's straightforward to add. There is still something about the way that we're doing the movement, that we're interacting with the entity, that is extra expensive. Because I can just mess with the entity's position once and we're good. So if I can identify why even remove straight line is burning so much time, then we'll have a better idea of what to do next. Exactly, Tess, exactly. I mean, again, this is a special case. There are plenty of game types out there that you could make that don't need this number of things. Pretty much any platformer, pretty much any first-person shooter, that kind of thing, you don't need this many, like, mobile objects. Most of the time you're going to be able to say, hey, draw a line. Did it hit something? Yeah, okay, we're good. You know, your classic fire bullets kind of thing. Even if you were to actually simulate every bullet, you're not going to easily get that many bullets in the air within a normal game. So, this is not something that's common. It's not something that, like, for my purposes, I can't find, like, tutorials or anything like that to really make this simpler. So, next targets, we have further investigation into this. Into this part of the performance issue. Additional investigation into the rendering, because that's costing us, as well as the creation of our entities, because that is proving expensive. I'm concerned that we might need to loop back around to buffering. We'll see. Because we know that was burning us originally, but maybe we can, maybe we have identified the actual cause. We'll find out. I do not have the next stream scheduled yet. Hopefully I will be able to maintain a more coherent schedule. Sleep and related scenarios are still kind of kicking my butt, so things are a bit wiggly as far as reliability of the streams right now, so please bear with me. In the meantime, I hope everybody had a good time coding with us today. If you like what you saw and would like to see more, remember to like, follow, subscribe, join, what have you. All of those things are good. They help the channel grow, and they will help you find related content in the future. With all of that said, did I already say that? I feel like I'm repeating myself when I do this. But in any event, I hope you have a good rest of your day, and I'll see you next time.